Okay, before we even look at this particular problem, let's look at this example over here so you get the idea of what's going on. Let's say I have a sequence that looks like this: 2, 5, 9, 14, 20, 27, and so on. This is not an arithmetic sequence because there's not a common difference, but the common difference is increasing by 1 for each term. So there's a difference of 3, a difference of 4, a difference of 5. So one way to determine the nth term, or in case the specific example, the sixth term of 27, is to realize that if you take the first term here and add on the sum of these differences, that you'll end up with the term that you're looking for. Because 2 plus 3 plus 4 plus 5 plus 6 plus 7 gives you the 27. Uh, but the 3, 4, 5, 6, 7, that is an arithmetic sequence. So we can use these formulas to determine that sum. So the sum of 3, 4, 5, 6, 7 is really the number of terms. If I'm finding I sub 6, the number of terms in the sum is 1 less than that, 6 minus 1. The first term is 3. The last term is 7, which I get by this guy right here, where if there's 6 terms, 6 minus 1 is 5. And that's where we get the 7. And you can see we get the 27. And generalized, if you want to find the formula for the nth term of this sequence, it's the first term plus the number of terms, n minus 1, plus the first term, which is always 3, the first difference, plus, and this is that 3 plus the number of terms minus 1 times the linear difference here, which if n is the number of the nth term here, then this is n minus 2, because the sum of the differences sequence has n minus 1. So this is n minus 2. And if you go through the arithmetic, you can actually come up with an expression for the nth term. And here I verify that that works for all of these guys. Okay, so if we look at these observations and number them 1, 2, 3, 4, and so on down to 13, and here are the observations, it turns out there's basically 2 ways to do it. We could find the first term, because 1, 2, 4, 7, that forms one of these sequences over here where the common difference seems to be increasing by 1. That's what I show right here. 1, 2, 4, 7. The common difference is 1, 2, 3. It keeps increasing by 1. And I can use this technique to get that 79. And then the 13th term, I'm sorry, the 13th term is 91, because we'll start at 79 and add on 12 differences. And then the average of all of these is actually the average of 79 and 91, which is 85. The other way to do it is to actually calculate the mean for each observation. And you can see that they're increasing by 1. 1.5, 2.5, 3.5. So you can actually calculate the mean of the 13th observation directly. We'll start at 1 and add on the sum of these differences between the means. And so how many terms are there in this sum? There's 12 of them. 13 minus 1. And there's the first difference, 1.5. The last difference is 1.5 plus 11 of these linear changes, which is 1 all over 2. It's the number, the sum of an arithmetic sequence is the number of terms times the average of the first and the last. That's this formula right here. And if you do it that way, you get 85 directly. That is the mean of the 13th observation. Okay. Of course, you could just list all 13 of these all the way down here. That would be brute force. And then add these up and calculate the average. But this gives you a way to do it for more than 13 observations if you wanted to. There you go. Hope that gave you some ideas. If you have any questions, post a comment.